All right, strap in everyone, because today we're diving headfirst into the quantum realm to tackle a question that's been bugging physicists for ages. Just how fast is quantum entanglement? You know, that spooky action at a distance that Einstein couldn't quite wrap his head around.
Yeah, it's one of those things in physics that just makes you scratch your head and go, huh.
Exactly. So to untangle this mystery, we've got a couple of sources to guide us. First up, a real brainy scientific paper abstract all about something called attosecond chronoscopy.
Don't worry, we'll translate that into plain English.
And then we've got a really cool article that breaks down the findings of this research in a way that, won't make your brain melt. But here's the kicker. We're talking about measurements on a time scale of attoseconds.
Now, just to give you an idea, an attosecond is a billionth of a second.
Yeah, it's like insanely small.
Yeah.
Like trying to measure the lifespan of a thought.
It's mind-bogglingly fast.
But that's what makes this deep dive so exciting. We're going to see how scientists are actually measuring things that happen on this ridiculously tiny timescale.
So, are you ready to have your mind blown by the speed of quantum mechanics?
Let's do it.
First things first, we need to get on the same page about what quantum entanglement actually is. It's this phenomenon where two particles get all tangled up, their fates intertwine.
Like they're connected by an invisible string, right?
Yeah.
No matter how far apart they are.
Exactly. And here's the weird part. Until you actually measure one of these particles, its properties, things like spin or polarization, are totally undefined.
So it's like they're in this limbo state, this cloud of possibilities, until someone decides to take a peek.
You got it. And the moment you measure one, the other one instantly knows, even if they're light years away.
It's like they have this secret telepathic connection.
It really is. So that's entanglement in a nutshell. But the big question here is, how fast is this connection? For a long time, everyone thought it was instantaneous. But now, with this attosecond stuff, well, it's shaking things up.
So it's like we finally got the right tool to zoom in and see what's really happening at this crazy fast level.
Exactly. Before, it was like trying to time a hummingbird's wing beat with a sundial. Now, with attosecond technology, we've got a stopwatch precise enough to catch these quantum events in action.
Okay, so tell me about this experiment. Our sources talk about scientists using intense laser pulses to knock an electron out of an atom. How does this relate to entanglement?
Well, it's like this. When that first electron gets ejected from the atom, it doesn't just fly off on its own. It leaves behind a partner electron that's still orbiting the nucleus, but in a different energy state.
Oh, I see. So you've got two electrons, each doing their own thing, but still linked by this quantum thread.
Right. And the fascinating part is that these two events, the electron getting kicked out and the other electron changing its energy, they're entangled.
So until you measure one of them, neither event actually has a definite outcome. It's like a coin toss, where the coin is both heads and tails at the same time until you actually flip it.
A perfect analogy. And this brings us to a really mind-boggling concept, the birth time of an electron.
The birth time. Now, I'm really curious, what does it even mean?
It's basically the moment the electron leaves the atom. But what this research has found is that this birth time is undefined until we actually measure it.
Wait, so it's not just that we don't know when it left, but the electron itself doesn't know.
It's wild, right? It's like the electron is in this weird state of maybe having left the atom at different times all at once. And get this undefined birth time of one electron is directly entangled with what's going on with the other electron that's still stuck to the atom.
Okay, my brain is officially doing backflips. So how in the world do scientists actually measure these super short timescales? And how do they even prove that the electrons are entangled?
This is where this attosecond chronoscopy thing comes in. It's a super clever technique that uses two different laser beams.
Oh.
It's like having two ultra-precise stopwatches for the quantum world.
So they're using lasers to basically choreograph this whole subatomic dance and capture the timing of these entangled events.
It's such a great way to put it. And what they found, well, I think that's a story for part 2 of our deep dive. Got to keep you on the edge of your seat.
You definitely got me hooked. We've uncovered so much about the weirdness of quantum entanglement already, and it seems like there's a whole lot more to explore.
So, are you ready to find out what the researchers discovered? It turns out that quantum entanglement, while unbelievably fast, it might not be instantaneous after all.
Wait, really? So there's like a tiny, tiny delay in this spooky action.
Yep, that's what this research seems to suggest. And remember, we're talking attoseconds here.
Right. A billionth of a second.
Exactly. So it's still crazy fast, like nothing we can really imagine.
But it's not breaking the cosmic speed limit. That's huge. I mean, why is this finding such a big deal? What does it mean for our understanding of quantum mechanics?
Well, for one thing, it challenges one of the fundamental assumptions we had about entanglement. But it's exciting because it opens up all sorts of new questions and avenues for research. I mean, think about it. If we can measure and understand these events at such an incredibly small timescale, who knows what we might be able to do with that knowledge?
Yeah, it's like we've unlocked a whole new level of precision in the quantum world. Pretty amazing. But can we back up a bit? I'm still a little fuzzy on how they actually use those two laser beams to measure everything.
Sure, no problem. So that first laser pulse, the super powerful one, that's what starts everything off. Think of it like the starting pistol in a race. It knocks that first electron out of the atom.
Gotcha. So that creates our entangled pair.
Exactly. Then that second laser comes in. This one's a lot gentler, though. It's more like a little nudge than a knockout punch. And it interacts with that ejected electron.
Okay, and what happens then?
Well, by carefully analyzing how that electron responds to the second laser pulse, scientists can actually figure out the timing of those events with crazy precision. We're talking out of second precision here.
Wow. Okay, so they're basically looking at that ejected electron after it interacts with the second laser to figure out when it left the atom.
That's it. And because we know that that birth time is entangled with whatever's going on with the other electron, well, that gives us information about the whole entangled system. It's pretty incredible.
It's like quantum detective work. They're using these lasers to piece together a timeline of these mind-boggling events. And what they're finding is totally changing how we understand entanglement. But honestly, the more we learn about it, the weirder it seems to get.
Yeah, it really makes you question everything you thought you knew about the universe. Remember that crazy idea we talked about? The birth time of an electron being undefined until it's measured?
Yeah, that one really blew my mind.
Right. Well, that actually raises even deeper questions. Questions about the nature of time itself.
Whoa, hold on. You're saying that time might not be this absolute, unchanging thing that we experience in our everyday lives.
It's definitely possible. I mean, if at this quantum level, the when of an event can be fuzzy until we actually observe it, well, does that mean that time itself is also subject to the rules of quantum mechanics?
Whoa, so you're saying time could be fluid, uncertain, maybe even entangled with other properties of the universe?
Exactly. And if that's true, it would completely change how we understand how reality works. It's wild stuff to think about.
My brain is officially fried. But, okay, let's say this is all true. What does it mean for us in the real world? What are the practical implications of being able to manipulate these quantum processes on such tiny timescales?
Oh man, that's where things get really interesting. Think about it. If we can actually harness the power of entanglement, not just understand it, the possibilities are pretty much endless.
Okay, I'm listening. Paint me a picture.
Well, let's start with quantum computing. Imagine computers that are exponentially faster than anything we have today, capable of solving problems that seem impossible right now. That's the potential of quantum computing, and entanglement is at the heart of it.
So we're talking computers that can crack any code, design miracle drugs, and create artificial intelligence that actually rivals our own.
Yeah, exactly. And that's not all. Entanglement could also lead to super secure communication networks. We're talking about transmitting information instantly and with complete privacy. It could even change how we explore the universe. Think about it, unlocking the secrets of black holes, dark matter, and maybe even understanding the very beginning of the universe.
Wow, it sounds like a whole new era of science and technology, all thanks to this crazy entanglement thing. It's incredible.
It is. And to think that it all started with this simple question: how fast is quantum entanglement?
And the answer turned out to be way more complex and mind-blowing than anyone expected. But that's what I love about science, you know. It keeps us on our toes, constantly challenges what we think we know, and forces us to reimagine the universe.
Couldn't agree more. It's a wild ride, and we're just getting started.
Well, on that note, we still got more to cover in this deep dive. So we've been on this incredible journey through the quantum realm. We've explored the speed of entanglement, the whole attosecond thing. And man, we've even talked about the possibility that time itself might not be what we think it is.
It's been quite a deep dive, and honestly, it just shows you how much we still don't understand about the universe and how it all works.
Yeah, it's both humbling and totally mind-blowing, right? I mean, we're just starting to peek behind the curtain of these big mysteries.
Yeah.
But before we wrap things up, I wanted to circle back to something you mentioned earlier. You know, this research could have a huge impact on technology down the road. I'm talking real-world stuff. Can you give us a glimpse of what those possibilities might actually look like?
Oh, absolutely. I mean, the potential is huge. Let's start with quantum computing. Imagine computers that are like insanely faster than anything we have today. Computers that can solve problems that would take our current computers, like millions of years.
Okay, that's pretty impressive. What kind of problems are we talking about?
Oh, all sorts. We're talking about cracking the toughest encryption, designing life-saving drugs, revolutionizing artificial intelligence. The possibilities are really endless.
Wow, that's a lot to take in. So we could be talking about things like super fast computers, unhackable communication networks. It sounds straight out of science fiction.
I know, right? But that's the thing about science. What seems like science fiction one day can become reality the next. And this research is definitely pushing us in that direction.
So you're saying we're on the verge of a whole new technological revolution, all thanks to this weird, wonderful phenomenon called entanglement.
It really does feel that way. And to think, it all started with this simple question: how fast is quantum entanglement? Who knew it would lead to all of this?
I know. And as we've seen, the answer to that question is far more complex and mind-boggling than anyone could have imagined.
Exactly. But isn't that the best part of science? It always challenges our assumptions and makes us expand our understanding of reality.
Absolutely. So to our listeners out there, thanks for joining us on this deep dive into the world of quantum entanglement. We hope you learned something new, maybe had your mind blown a few times, and most importantly, we hope we sparked your curiosity.
Yeah, that's what it's all about. Keep asking questions, keep exploring, and keep your mind open to the possibilities, no matter how strange they may seem. Because as we've seen today, the universe is full of surprises.
Couldn't have said it better myself. Until next time, keep diving deep.